Hey everybody, welcome back to my channel. Atlas Unit 22 here, going through my Nerf Hyperstrike build. Currently I'm thinking of how I'm going to rewire this. I've had this operational with stock motors and it works. In theory, what I built to work, but the wiring is a mess and I really dislike it. I want it to be a little bit cleaner. And I use these plastic, I don't know what kind of wiring this is, but it's plastic wiring. Don't like it. I'm going to swap it out for high temp flexible silicone wiring like I did for the motors here. And what you call it, I had to figure out a new way to, not a new way, but a way to wire this so it can use a relay, which I've got in here. This is an automotive relay that can handle 12 volts at 40 amps constant, not instant, not for momentary, but constantly 40 amps at 12 volts, which is overkill for what a Nerf is, what you need for this. Alright, but as far as I understand it, the more power you can get to the motor from the battery to the motors, the better, right? Anyways, so I drew a schematic of how I'm gonna be doing it. I mean, we don't have to use a relay, but I'd rather use a relay because that's what flywheels are. You have either no power or full power. That's what a relay is for. I've seen people use a MOSFET in place of a relay, but that's prone to burning out, as far as I see it. But anyway, oh, and MOSFETs are designed for modulation. I believe the term is modulation. Power modulation or variable speed, which is not what you want for a flywheel, unless that's what you really want. It's just like ruins the point. But anyways, so here's my schematic diagram, and first we got a power source, 12 volts. You're gonna have a negative, positive, obviously. Then you got your rev switch, a relay. Now relay is something is a little magical, I guess, if you don't understand, but this is the way I would go with. And then you also got the flywheel assembly there. I'm not gonna get too much in depth into these three here, but this guy right here is the meat and bones of that makes this whole system function with full power. So when you turn the rev switch on, you're really just you're creating a complete circuit between the power source and the signal or the actuation side of this relay. Right, and once you close the circuit, there's a coil in here that closes another contact inside the high powered side, and then that transfers the power from your power source through the high power contacts in your relay right into the flywheel. The advantages of this is that you could have the battery wherever you want, as far away as you want, without the wiring limiting your length of what you can do, I guess. Normally you would just have a switch in line with the power source right to the flywheel. The problem with that is if you get too high of a power or too much amperage going through the switch, you could possibly overheat and melt and possibly fry your switch and your Nerf gun. With this setup, the bulk of the power source, actually, I guess you could say all the power source, it's going through the heavy 14 gauge wiring directly from the power source through the relay to the flywheel. Now this relay can handle a constant 40 amps at 12 volts, whereas I don't know what a MOSFET can handle, but I know 40 amps is overkill. MOSFET can handle a flywheel at idle, I believe. This thing can handle the idle of these Neo Hellcats, no problem, because I believe idle current draw is only 0.75 per motor. This thing handles 40 amps, which is 4,000. Is that right? Yeah, 40 times, a little over 50, I think. 40 times what idle current is for the build here. But anyways, that's for the flywheel relay. And then my other thing I was thinking is adding motor braking to the build for the conveyor belt, because I've noticed that when I was using it without a braking, it would push a dart and get it stuck in the flywheels. So same thing, you're gonna have the power source, which is a battery, connected to the switch through ground, and the ground